This is my final video for a school assignment where we are to choose a task implemented in Unity through a shader, and then describe the shader and also what the shader is trying to do. So what I will do in this video is describe the problem I have chosen, the shader I want to implement, and also I would like to go through the code which implements the shader. It does the effects in Unity, and then I'll try to come with some examples on how to use it and why it's good to use and things like this. So let's begin the video. I'll explain to you what task I've chosen. I want to go through the Fresnel factor for specular highlights, and this real-world phenomenon uses Slick's approximation to calculate the mathematics in the formula, and what I have highlighted here is the Slick's approximation of the fractional factor, and I'll go through this also in the shader code. But as you can see down, so let's zoom. If I go down the page, you can see we actually use the lerp function in Unity to do the calculation. So the lerp function goes from the Fresnel factor, which is set, and down towards 0, and then it moves with a specific sort of range down. So down towards this number we have set to 1. Okay, so this is the mathematics used in the shader, and now I will go into Unity in just a little moment and show you how the shader is implemented on objects and how this affects the material due to the light settings in the scene. So as we see, the Fresnel factor is shown on this picture from real life, where the light is coming from the back of this picture where the marker is, and we see the silhouettes and the sort of glow effect from this. The material creates this textile cloth material, and also it shows on the hair, and actually this glow effect and highlight is created from the Fresnel factor. Okay, so now we will move into Unity, where we can talk about the shader. In this project I have added some objects already. Some of the objects has material applied, and some has just the material is actually just a color. So these two cubes has also specular shaders, but since they are cubes and the light is positioned the way it is, it's not very obvious how they affect this. So let's talk about the shader that I have implemented, which implements the Fresnel factor. This is this object I'm pointing on now and selected. This object has Fresnel factor applied. We can see the light source is from directional light, which comes from where the marker goes down here, hits. So in the back of this we don't get any light, so we will not get any highlight on this side of the object. It's basically the same with the other object behind it, this one, which has a different shader applied. I will go through that later when we try to compare the shaders. So the front object here, this shader has a Fresnel effect applied, and I've changed some of the parameters already. So let's go back to some original settings, and that's I've modified the code in mono, so we can actually choose on our own how we want the exponent to in the formula to be high or low according to the sort of result we want. So this is just normal. Let's change it to, actually we can see it better down here in this preview of the material. So if we change it down to 5 where we had it before, that's not the biggest change, but if we go change the exponent to say 30, there will be a slight difference in how the Fresnel is applied. When we have an exponent of 1, which will not give us any specific result, we have a very clear highlight with sort of it's still color blend, but sort of a white tone to it. And the higher we go with this exponent, the sort of the highlight spreads out over the material and also gains a little more color from the material into it. Okay, so this is kind of the controls. We can also change the colors from the material, of course, but I'm not going to go into this. Actually, let's see another view of this from a camera view, where we see the light. The light is the same for both objects, but since this both have diffuse reflection and also specular reflection, it gives a totally different surface than this Fung reflection model, which only has the specular highlight applied and the specular reflection. So the Fresnel factor also has the diffuse reflection in the calculation. Let's go into the code so we can talk a little bit more about this. Just start from the beginning of the code, where we have a shader. It has a subshader which is divided into 2 passes. Of course, we also have the properties which you saw earlier. These can be changed according to what we want as user of the shader, what sort of environment the shader is put into the material game object. In the beginning of the first pass, we have an option for the shader, which is the light mode. The light mode in this pass is set to forward base, which actually applies all the lights in the lighting pipeline. And here we both have ambient, directional, vertex and specular highlights applied onto the scene. So if we enable these, it will be a part of the pass and the calculation in this pass. The first pass is consisting of a vertex shader and a pixel shader. In the pixel shader, we just calculate the view and the object placement in the coordinate system, and of course we also use uniforms to set the different parameters for the object and the material, and also we use uniforms to create matrices to calculate the transformation and orientation and so on. We take, of course, position of input, and also we calculate vectors from these coordinates. And as the vertex shader in the first pass, as I just said, it calculates the camera and the object placement, and in the fragment shader we see how the light is affecting the material, and it's within the RGB color spectrum. And in our case, this one with the Fresnel factor, we also take the alpha channel into account, which is sort of the transparency level of the object. And since Fresnel factor is also applied to semi-transparent objects and textiles, hair like this is of course also, and like water, this is of course important to address. In the fragment shader, we look what type of light is in the scene, if we have a directional light or if we have point light or spotlight. This calculation is being used in the slicks approximation, where we also use the ambient light, we also use the diffuse reflection, and we use the specular reflection. The diffuse reflection is multiplied with the opacity of the object, and the diffuse component of the object is of course the material or the texture. So So I'll just apologize if I'm a bit silent. It's if I'm looking at my papers or if I'm just catching my breath. So this the pixel shader is doing the calculation of the light according to both color and what type of light is applied and how the shininess is set. The shininess can sort of be considered as how close or far away the light source is to the object, because if the shininess is very high, the highlight on the object will be very small and concentrated, which could resemble a close light source. But also if the shininess is very low, the beam will be sort of spread out over the material and create a smaller highlight on the object. So what we get in return from this fragment shader is both the values of the ambient light and the diffuse reflection and the specular reflection, and also we have the directional light applied. And also in this calculation we look if what type of side of the object, what side of the object the light is coming from, because on the back side of the object we don't have any highlights at all if we don't have light. So of course it depends on if the ambient light is activated, and I will show you this back in Unity when we go through how the shader can be used. Okay, so we've been through the pixel shader and the vertex shader in the first pass, and let's go down and here you see in the specular reflection we have the calculation from we use the lerp function, which is sort of like doing the calculation of the Fresnel factor for us. So the next pass, we also have an option set here on the light mode, and it's forward add, which applies the additive per pixel lights. The per pixel lighting gives a much more obvious concentrated highlight compared to the vertex lighting, per vertex lighting, because it calculates the whole surface instead of pixels on the surface. So okay, in the second pass we have the same properties used in the first pass for determining the color and the diffuse material and the shininess and how the exponential change is going to be in the formula. And actually what is being created when we use this this Fresnel factor is that we build beyond the Fung reflection model. The Fung reflection model is what we use when we use the specular highlights, when we just get one sort of bright highlight created from the light source with no sort of blending from material color and from diffuse material and specular material reflection. But what happens when we use the Fresnel factor is that we create the blind Fung reflection model. In the Fung reflection model, the angle between the view vector and the light source vector cannot be more than 90 degrees because then the calculation will not take all the factors into account, all the light intensity into account. And when we use the blind Fung reflection model, we use a halfway vector calculated from the view vector and the light vector, which gives us sort of like the normalized vector, and this will always be lower than 90 degrees, which will give us the chance to take all light setting and material settings into account. So this is sort of an advantage with the blind Fung reflection model compared to the Fung model reflection model. I can show you this, as I said, when we go through the examples on how to use the shader. Okay, in the second pass we'll just have a vertex shader and again a pixel shader, but the second pass is set to return only diffuse reflection plus specular reflection and the directional light setting. It's not taking the ambient lighting into account in the calculation. So this is the big difference from the first pass and the second pass, that in the second pass the ambient lighting is not applied, because we can in Unity choose to have ambient lighting or choose not to have ambient lighting, and now I will show you what the ambient lighting, how it affects the shader. So we go into the render settings and we try to change the ambient light from a very dark, non-existing type of light to a more bright light, where we see the back side of the where the marker is on the object. From completely dark, we use the other pass in the shader to sort of like create more light on the material, because the ambient light is coming from everywhere close to the objects. Okay, so now I've been through the shader and I've been through the code of the shader, I've been through the implementation. Now I'd like to show you how this is just the picture to get us started, but I have some other pictures also where the Fresnel effect is used in computer graphics in creating water particles, and we see the reflection here on the surface sort of having this glow effect, the same as the silhouette from the picture I showed you earlier. I also have the picture here so you can see it again. So the Fresnel factor applies some diffuse type of diffuse parameter to the light reflection on the surface, compared to original specular highlight, which doesn't take account this diffuse reflection but only the specular reflection. So also the difference between, now you saw these computer graphics images where we use the Fresnel factor, but we also see the difference here on the two objects, where we have the specular highlight here and the Fresnel highlight here. The specular highlight doesn't take the diffuse reflection from the material into account, only the specular color. So specular reflection. Okay, so I'll just look to see if I have more to add to this. I hope that you heard it all and there's no problems with the video. This is the final recording I'm making, and of course Fresnel gives again a strong reflection, and we cannot say that the Fresnel factor in real life only exists when using one sort of material, because it appears both when using textiles and also strong metals, because the glow effect will happen when the light source is sort of from the same angle as this picture I showed you earlier. I've closed it now, but the woman where the light source is away from the camera, and we see the silhouettes in the clothes and the hair. So also I'd like to add that the more transparency the surface has, the less specular highlight is being taken into account in the mathematical formula, and more diffuse reflection is being added to the result. And of course the diffuse reflection creates a more spread light setting, where the specular highlight creates a more concentrated highlight on the object. So the modification, and here in the Fresnel factor we've also been through this, changing the exponent to give an exaggeration effect on the Fresnel effect, sort of like blending more or less the colors used both diffuse material and specular material. So this is all for this tutorial and all for this assignment. Thank you. My name is Nikolai. Bye.